Hi everyone, it's Has. Today we are going to continue with our tutorial. So I'm going to perform a nonlinear static analysis, right? So the easiest way is to go directly on the geometry. But quick note, if you don't want to miss future tutorials, there's the link in the description to get notified, right, of this video. So let's go, part one. So as it's non-linear, I designed my geometry already on Katia. So I'm going to use it, right? So I go here, File, Import, and I go Part here. So I'm going to search for the location. Where did I save my cat? No, it's a step file. So here, Abaqus, and I will change the file filter and put a step. So now I have my plate with a rivet, right? So if you want to change the name, you can. If you want to keep it, you will use part name from file, right? So that's okay. So you hit OK. So now it imported, right? I can see the rivet here. So if you go on part, you can change and go PS1. So this is, let's go and say, I can change the name and name it as plate, right? So I can right click and go rename and write plate. So now we're fine. So what I would do is the property first, okay? So I go property here. So I can start with here and go steel. So this is gonna be a steel material, general density. My geometry is on millimeters, so it's 7.9. And here is going to be -9, right? So let's go mechanical, elasticity, elastic, and you go Young modulus to 100,000 and Poisson ratio is 0.3. So now what I will do is I think this is okay. So if you guys want to know how to manage and assign plastic properties and stuff, you can ask me below and I will tell you how, right? But in this video, we're not going to need it. So I will erase the plastic one and let's move on, right? Okay, so now let's create section one, and homogeneous solid, continue. So this is the steel, the one I created. Okay, so now let's assign the section because we created the section, but we didn't assign yet. So I click here, I hit done, and then okay, and now we change and put to the river and assign the river as well. So we can also see the changing color that tells us that it's being assigned. So now let's go on assembly, right? So in assembly, we need to tell the softwares the part that we want to work with, right? So let's hit here. We have two parts. We have the rivet. You hold the shift button, you hit this, and you go, okay. So now we're fine. So I can do this. Yeah. So what I will do right now is to go on the third step here, the step. So what I will do is a first step, let's say loading or pushing, displacement, whatever you want, or step one, the way you want. So I'm going to push this rivet to the plate and there is a hole, and I'm going to move it very aggressively in order to see how this plate will behave and study the stresses that we will have and see if the material fails. Okay, so what I will do right now is to create a step. So step one, let's say moving or loading. So yeah, so let's say displacement, because this load I'm going to apply a displacement here. So let's do this. Yeah, general. So static general. Why static general? Because it's a nonlinear static analysis, so I can use the static general. Okay, you can also use the dynamics one, but we're not there yet. So for first rounds or first simulation or first try, let's use the static general for a generic consideration, and we will see what happens next. So continue. So now we are in the time period. So I prefer to go 10 seconds. So this is really, really great. So now we have a bigger time period as it's a nonlinear static analysis, so it's always better. So here, nonlinear geometry is off. We need to set it as on, because if you put as on, that means now the software understood that we are performing a nonlinear static analysis. So you go incrementation. So this is really, really important. So it's 10 here for initial, and here is 10 as maximum. So I don't agree with this. Okay. So let's go 0.0005 here. And here, let's add some zero. 1, 2, 1, 2, 3, 4, 5, 6. I think I'm going to put another one for 7. So maximum here, I'm going to put 1 for maximum. So this is what I want to have. Okay, this is very good for this. So, but again, you will do this, and then you will run your results, and you will see based of the results you have, you can adjust the steps and see. But again, if you have experience, you start knowing these things instantly, right? So I'm not saying this is the best way to do it. What I'm saying is that this is for beginner and intermediate. So I try to do something that you can understand, right? So that's why I do it this way. So, okay. So what I will do right now is the interaction. Okay. So these parts are going to touch one another. So yeah, so we're doing interaction here. The interaction, basically, I'm going to create the contacts, right? So I'm going to create the contacts, or to define the contacts through the interaction module. So I know that, let's do this because I'm going to move my rivet. So I know this surface here is going to touch this one right here, and I know the surface around the river will touch the hole here inside. So that's what I'm going to define, right? So I hit here the first interaction, so I can even write it as contact one or interaction one. Okay, it's fine. This is the first interaction, so surface to surface contact. So yeah, because I'm going to use the surfaces, so this is fine. Here, the steps one, the displacement. Yeah, I'm not gonna start with the initial, because initial is where you didn't apply anything yet. So I'm going to use the displacement, because that's where I'm going to start applying my boundary conditions, right? Or the loads, if I will, because I may not use the loads, but only a displacement, only boundary condition, but we will see. So surface to surface contact. We also have other ones, self contact and stuff, which is the standard one, but let's use the surface to surface contact for this. Let's go continue here, and I'm going to click. First of all, it's better to click this one, the one that will move to go and touch the other one. So this one we call it as the master, and the second one we call it as the slave one. So surface, and I will click here, and I hit done. So now we will define the type of contact here. So it's a contact, and I will write contact one. Okay. So contact one is a contact. I hit continue, and let's go mechanical, because this is a mechanical contact. Is it a tangential, normal behavior, and cohesive behavior is the most realistic one, right? So yeah, but for first analysis, or for this one, because it's I want to go really faster, because cohesive require more elements, and it takes time, and it's very costly. So let's go normal behavior. Okay, so normal behavior, and is hard contact. We can go on other types here, tabular and stuff, but I'm gonna stick with the hard contact, right? So yeah. So if you want to know more, you can go and click the link below, and you will be in touch with me, and I can offer you those kind of tutorials, right? So yeah, or don't hesitate to comment below, and I will tell you. So now we're fine with the normal behavior. So let's go okay here, and I have it here. So let's go this. So you can see this red triangular rectangle here. That means that the interaction has been took into account. So what I will do right now is to create the other interaction, right? This is just part one of this video, so let's see you in the part two. Okay, so if this video helped you, the link in the description will notify you when the one's out. That's the easiest way to stay in the loop, right? So yeah, peace.